In this video we are going to discuss about the ion selective electrodes. So by the end of this section the students will be able to understand the operational principles of the potentiometric electrochemical transduction. They can able to analyze the selectivity mechanisms of solid state and liquid membranes interfaces. Also they can able to evaluate how these configurations will isolate the specific clinical electrodes such as potassium, sodium and calcium. This ion selective electrode is actually a high specialized electrochemical sensor that is used under the domain of potentiometric sensors. So this purpose is mainly used for converting the chemical activity of a specific ion into a dissolved solution, that is directly into a measurable electrical potential. So in case of amorphic sensor, that look at the current potentiometric devices, but this will be measuring the electromotive force or voltage while drawing the zero current. And to understand how we extract this clean potential is, a working system will always require the two pillars, that is it should have ion selective sensitive devices as well as stable external reference voltage. So the sensing electron will houses the internal reference element, that is silver or silver chloride. In the case of this solution will be sealed at the base. When both the electrodes are placed in the patient sample, the selective migration of the ions at the outer membrane will generate a phase boundary potential, because the internal variables and the reference electrode are completely fixed. And in the case of liquid membrane and polymer based electrodes, these sensor will utilize a hydrophobic liquid phase which will be containing a dissolved ion exchange substance which is structurally trapped with the porous support like PVC. So this potentiometry is clinical example for the potassium selective electrode, which integrates the natural as well as neural antibiotic carriers, and here this enables to incredible selective ratio by allowing the clinicians to measure blood potassium accurately even in the massive background sodium concentrations. So if you see this crystal lattice parameters with the solid petals, means there will be, it permits only the target ionic specifications. So it allows to hope between the vacancy sites and establish the charge balance. So here this will offering the immense mechanical stability for maintaining the long operational lifetimes. And these are the types of the electrodes: redox electrode, ion selective electrode and PCO2 electrodes. So finally these types of electrodes are used in the clinical applications where they allow the near instantaneous tracking of essential physiological electrolytes. And today these individual macro electrodes are being very struck down in the cartridges, and also enabling the point of charge testing units for calculating patients' full metabolic electrolyte profiles within the seconds from just a single drop of whole blood rate right at the bedside. So these electrodes are mainly used for potentiometric applications.